Guys, so in this video for the calculus test coming up with our application of the integrals, I'm going over just some of the questions here throughout the review, like one from each section. So like here, I'm going to go over number 2. So again, if the question says find the average value, don't forget about that fraction here or when we're dividing. So like for example, we're going to find the area, right? So we're finding the area from 1 to 5 of 1 over x squared. Now, I'm going to go ahead, though, and rewrite this, right? Because 1 over x squared is the same as x to the negative 2. But then remember, because we're finding average value, here we're covering 4 units from 1 to 5. So then we're going to multiply by 1/4 in this case, divide by 4. So now when you get the integral here, and after adding 1, you now have a new exponent of -1. But then don't forget to divide by -1. So when you rewrite this fraction, because notice with x having a negative exponent, it's going to go now in the denominator. Then here, that means I need 1 as my placeholder and negative. So because we divided by a negative. So our integral here is -1 over x. Then don't forget now, right? We're focusing on from 1 to 5. So here, when you substitute 5, remember this is a -1 over x or -1 over 5. Then minus, now substitute 1. This is -1 divided by 1, which is -1. So that's why notice here we've got to add 1 to -1/5. That's how we get 4/5. But then don't forget, we're finding the average value. So then multiply by 1/4. So that's why the average value here is 1/5. Then here for the next section, I'm going to go over question number 4. So now notice here, go with the question. We're now going to find the x value where it is equal to the average value. So we still need to find the average value here, right? So in this case, this is from 0 to 3 and 1/3 because 0 to 3, 3 units. And we're going to find the integral here from 0 to 3 of 3x squared minus 2. But just remember, whatever we get here, right, our average value, we set that equal to 3x squared minus 2 and then solve for x. So now let's go ahead and focus on what is the average value. So here we're going to get our integral, which is x to the 3rd, right, because add 1, divide by 3, minus 2x. Then here, substitute from 0 to 3. So when you substitute 3, you get 21. Minus, when you substitute 0, you get 0. So here is 21, right? But remember, we need 1/3 of 21. So don't forget to get the average here. So 1/3 of 21 is 7. So now we've got 7 is equal to 3x squared minus 2. Set the average value equal to x and solve. So now here, we just solve like any other equation, solving for x. Add 2, 9 is equal to 3x squared. Now divide by 3. You end up, oops, sorry about that. You end up with 3 is equal to x squared. So here, that's why we end up with the x is positive negative radical 3. So again, get the average value here overall, right? The average value was 7. Then set that equal to your x value function here and solve for x. So now with our application problems, I'm going to go over number 6. So now this one, we're talking about the temperature, right? Now T is in hours. So notice our start is 9 o'clock a.m. So think about that as like our 0. That is our start. And we are approximating our temperature function here by, here's our function. We're going to find the average temperature during the time period of 9 a.m. to 9 p.m. Well, think about it, right? If T is our time in hours, how many hours have passed? 12 hours. So our average, right, is then going to be 1/12 because what are the boundaries? Well, we're starting at 0 and going to 12. So that is representing the amount of hours. I don't want the time, right? We want the number of hours. Then we're going to find our integral here of our temperature function. So that means here you end up with 8x, then minus 14 times sine, oops, sorry, not x, t here, sorry about that, minus 14 times sine of t. So then here, remember, right, you have to change, oh my goodness, I even put sine, minus 14 times cosine of t. So here, right, because remember the integral of sine is negative cosine. Then we're going to focus on from 0 to 12. So then substitute, 12 in for t. So now when you substitute 12 for t here, you end up with about 82.3. Then minus, go ahead and substitute 0. When you substitute 0, you get negative 14. So notice you end up having to add these values together. So this gets us about 96.3, but then degrees, right? But then don't forget, we're getting the average. So then now we take 1/12 of that, and that's how we get about 8.025 degree change in that temperature. So now with our area between the curves. So with respect to x, I'm going to do number 8 because when you graph, so here the y is equal to x cubed minus 3x is what's in red, and then y is equal to x is our graph in blue. Notice how our red switches position. Oh, there goes NOLA. So that means we're having to find the area here from -2 to 0, but we're also finding the area here from 0 to 2. Notice we have to create two separate integrals because our x cubed function is the top, right? So remember, when it's with respect to x, top minus the bottom. So, but then notice from 0 to 2, when we have to find the area of this section, it was then below. So because of the switch, that's why we need two separate integrals that we are going to combine together. We're going to add them together. So again, x cubed is what's up top, so that's our f of x. X cubed minus 3x minus the bottom, which was x here. Then plus, then we switch, because notice how x is what's up top. Then minus our g of x, which was, notice, x cubed minus 3x. So then here, I'm just going to, if you notice with simplifying, so this becomes -2 to 0 of x cubed minus 4x, because that's -3x minus x. We're going to add to that from 0 to 2. Notice here now, negative x cubed, because now negative and a negative makes this a positive 3x here. So that's how we get x plus 3x, which is now plus 4x. See again, notice we're changing the signs because we're flipping. So that's how you can also tell you're good to go. Then we get our integral. So here we've got x to the 4th over 4 minus 2x squared. And that is for our first section here, right? So from -2 to 0. Then don't forget we're going to combine with that negative x to the 4th over 4 plus 2x squared from 0 to 2. That is the area of this function here. So now we start substituting, right? When you substitute 0, you get 0 minus, when you substitute -2, you get -4. So notice here, with the two negatives here, the area of this first section is 4. Then we keep going here. We're going to substitute 2 in now first, right? So 2, you end up with 4 minus, when you substitute 0, you get 0. So notice now the area of our other section here is also 4. Combine the two sections together to make it a total area of 8. So now here, I'm going to go over number 9 because this is with respect to the y-axis. So now notice, if it's an axis like here, then this is like x is equal to 0. So we have our x equals function here, and because we're working with the y-axis, this is like x is equal to 0. Now remember too, this is with respect to y. So now this is right minus left. Notice how our y-axis is what's on the right, and here our function, the y squared, is what's on the left. So here, we're going to set up 0 minus y squared minus 3y minus 4. And remember the boundaries, right? Because this is with respect to y, we want the y values, which are -1 to 4. So we're going from -1 to 4. Then notice here, right? Don't forget to distribute the negative. Like this is negative y squared plus 3y plus 4. This is what we're finding the integral of, which is negative y to the third over 3 plus 3y squared over 2 plus 4y from -1 to 4. So now substitute 4 in for y. When you substitute 4 in for y, you should get, and make sure you practice, right? You should get 56 over 3. Then minus, then substitute -1 in for y. Again, practice, and you should get -13 over 6. So now notice again, you're ending up having to add those values together and get an area of 125 over 6. So just remember, right, with respect to x, top minus bottom, and you're focusing on the x values. Y, right minus the left, and you're focusing on the y values. So now I'm going to do a few of the integrals here. So like I'm going to go over number 12, 14, 15, and 16 on this screen here. Then, just a heads up, I will also go over number 17. So if you're like needing me or wanting to see just getting ahead one of these, then of course, just go through, fast forward, right? So here we go for number 12. This is U substitution, because notice we're dividing by an expression. Remember the expression, that is our U, 5x squared minus 4. Then get the derivative. So the derivative here, du, is 10x times dx. So now notice we have 10x dx. So that means we'll go ahead and put 1 in its place over, now we use u. Then what is the derivative of derivative? What is the integral of 1 over u? Natural log of u. So that's why here we have the natural log of the absolute value of 5x squared minus 4 plus c. Now, number 14 is not u substitution, because notice we're just dividing by this one term here. But this is going back to, like, if you needed to rewrite it, like this is 12x, right, to the first power minus 10. Notice there's no x, so think about it like it's 0 over x to the 1/2. So simplify this, right? We're going to find the integral of 12x to the 1/2. 1 minus 1/2. Then minus 10, think about it, right? Like it's 0 minus 1/2. So x to the -1/2. We're going to find the integral here. So then just like before, add 1. So now x has a new exponent of 3/2. But don't forget to multiply 12 by the reciprocal 2/3. then minus, then when you add 1, x is now 1/2, right? Negative 1/2 plus 1. But don't forget to multiply 10, not by 1/2. That's been the common mistake. Multiply by the reciprocal, which is 2/1 or 2. So that's why here, when you simplify 2/3 times 12, you get 8. 8x to the 3/2 power minus 20 x to the 1/2 power plus c. Now here, if you need to, so that you rewrite this, remember this is the same as 4x to the negative 2. So when you find the integral, right, add 1, you end up with an exponent now of negative 1. So 4x to the negative 1, but don't forget, divide by negative 1. So I'm going to go ahead and rewrite this. So remember, because it's x to the negative 1, this is now going to go in our denominator. And now we have negative 4, right? Because we divided by negative 1. So this is negative 4 over x. Then plus derivative, I keep saying derivative, my goodness gracious. The integral of secant squared is tangent x. No sign change, right? Plus c. So now 16, again, this is not u substitution because you're just dividing by x squared, one term. So this is when we go through and rewrite or simplify. So this is now 9x squared, right? 4 minus 2 plus. Now, yes, these cancel out, but that's not just 0, right? Well, what's x squared divided by x squared? 1. So plus 1. Then minus. Notice how this is like 11x to the first, so 1 minus 2, which is negative 1. So this is 11x to the negative 1, or 11 over x. So now we find the integral here, which is adding 1, so x to the third, but divide by 3, so 3x to the third, plus x, because we had plus 1 here. Then minus, notice here, just like our 1 over x, natural log. So this is 11 times the natural log of x plus c. So again, notice that difference, right? When we had our u substitution versus having to simplify. And so the last one I'm going to do is 17. So notice, this is not just e to the x, it's e to the x squared. So this is u substitution. U is x squared. Now we get the derivative. So du, derivative, here is 2x dx. So now notice, we're solving for dx, right? So now divide, because we don't have 2x times dx. So I'm going to go ahead and divide by 2x. So that's why here we need to divide 6x by 2x. Now notice here, the x's will cancel out, and so that's why we're just left with 3. Then times e. Now remember, right, x squared is now u. So 3e to the u du. So now we're going to find the integral. Well, that's just 3 times e to the u, and u was x squared plus c. And that is our integral here.